So again, we've got our known y's. So they all three of them work the same way. Okay. There's our r squared, which is, again, the same as what we have on the model. Okay? So there's three potential exam questions right there. Given this set of data, what's the slope of the line? What's the y-intercept? What's the r squared for this model? And already you could calculate this two different ways. One, you can take the time to put together a scatter diagram and then right-click and do that there. Okay? This gets a little tricky because when you get into real big or real small numbers, you start getting into rounding issues here. Plus, it takes a lot more time. For my money, it's a heck of a lot quicker to do it that way. Okay. All right, so far so good? All right. The most rigorous way that we can use Excel to do this linear regression is through our data analysis package, okay. Which will pop up right here. Pay attention. When you get on the exam, because you're going to have to do this, I think you have to do it on this exam, but even if you don't, you definitely have to do it on the final exam. So pay attention to this. I posted a video this morning, just at Joe Bear's request. Posted a video this morning if you forget how to do it or whatever, so you can go on there. But pay attention to this process. We need our data analysis pack, which is under the data menu, and it's not there, okay, because it's what's called an add-in. So we have to actually add it in. And the reason you have to do that down in the computer lab is because every morning, I think at like 2 in the morning, they wipe everything out down there. So the computers reset every night, right? So it's never on there. So when you get on the exam, you're going to have to actually do this sooner or later. And the way that you do it is if you go to File, and then Options, and Add-ins. Okay, so that was File. Excuse me. File, Options, Add-ins. Okay. If you do that, then you have a whole menu selection of add-ins. All right. Honestly, the only three I've ever used was the Analysis Tool Pack. Okay. And I usually just put in the VBA. So I don't remember. Yeah.
Where is it on the Mac? It's not under File. I don't see Options.
I don't think you can get it on Mac.
No?
Yes,
No, on a Mac, I have Solver. This is one of the add-ins. And on the Mac, I had to go, I did it so long ago, but there's a website where you go and you have to actually download Solver. So yeah, I'm glad you brought that up. It's not, these add-ins are not on the Mac. But on the computer lab computer, you're not going to have Mac. So. But yeah, there's a website. Sir?
Is VEA in 2010 and VBA in 2013 the same?
I can't hear you.
Is VEA in 2010 and VBA in 2013 the same?
It's probably not the same, but I'm sure it would get you what you need for what we're doing. So yeah, I'm not sure. I imagine they call it VEA for a reason as opposed to VBA.
Right.
I don't know what that reason is, but I'd be shocked if it didn't get you where we're going. So if it doesn't, let me know. Okay. All right. So what we need to do is we want to add in this analysis tool pack. Now, when we get to the third of the course, the investment part of the course, we'll be adding in Solver at that time. Okay. So like I say, you need to know this step. All right. So add that in there. Click Go, and for some reason you have to click Send. So again, here's your analysis and your Solver if you want to add that in. And just click OK. And now notice that under the data menu, your data analysis pack pops up. Okay, so let me pause right there because you're going to have to do that on the exam. Like I say, I think you have to do it on this time. I know you have to do it on the final. And you'll see me do it again because they wipe out these computers too every morning at like 2 a.m. So you'll see it again. And I posted a video on this morning. So everybody with me on that? Okay, so this gives us our most rigorous information on regression analysis. So if we pop in here, we have all sorts of things that we can do with our data, a lot of which I'm sure looks familiar to you from your statistical courses. Okay. And one of them, of course, is regression. Okay. So if we choose regression, whole bunch of choices here, kind of cutting to the chase, the same thing we just did, x variable, y variable. You know, we can do some statistical things here. The other thing you want to be aware of is the output options, because the default is a new worksheet. So if you don't change this, what it's going to do is it's going to create a new sheet in here. So in fact, see right there, regression results. It'll put a new sheet in there, which can be a pain depending on what it is you're doing. So what I'm going to do for convenience, if you hit output range, and I'll just put it right here with sub inputs. Okay. And you click go, and you have a much more rigorous regression analysis with the statistics. Okay. Now, a little time saver here, because there's no formatting of this. When you do this, notice how everything is selected. So while everything's nice and selected, I'm going to format it to make it a little easier to deal with. Okay. All right. So let me pause right here. Questions about that? Okay, so when we do that, notice, first of all, that we get the same results. Okay, so here's our intercept, noticing it's a negative number. Our slope, our r squared, 96. Okay, this gives us our adjusted r squared, okay, which is 95 in this case. So if we were looking at statistics, then we would default to our adjusted r squared, and a bunch of others. You know, your f stat, here's your t stat, your p values, and all that kind of stuff, confidence intervals, and all that kind of thing. Okay. Mm-hmm. All right. So with regression analysis, 3 ways to do the same thing. Questions? Questions so far? Okay. Well, this is what we're going to use as a forecasting tool. You know, and I'm gonna harp on this every time we talk about forecasting. We're all trying to come up with the perfect forecast. Okay? We're all doing that. Right? So again, this isn't about how do we get to the perfect forecast, because if I knew that, actually I wouldn't tell you. If I could forecast a stock perfectly, I wouldn't tell you how I would do it. Which is important, a little bit off topic for the moment, but important because the next time someone tries to sell you a trading rule that supposedly works like a charm, why would they do that? Okay. We can talk about that, and we will talk about that when we get into investing. Okay, so this is one approach. Pulled an example. I presume this is off the. This is out of the textbook, some data that they gave us there. Excuse me. Okay, so this is a very simple example of forecasting. All right. So what we have here are sales for 5 years. And of course, those 5 years. And what we want to do is develop a forecast based on this for the next 3 years. Okay? And in this very simple example, the only purpose of which is illustrating linear regression as a forecasting tool, our x variable is going to be the year, and the y variable is going to be the sales. In other words, what we're saying is that sales are a function of the passage of time. Because if we were doing this in a more real-world setting, like I have an example of that we'll get, if we get to it, I'll show you. The question is, well, what do we reasonably expect to drive sales? And what would you? I mean, if you were looking at a company from the outside in, what would you expect to drive sales?
Advertising.
Okay, maybe the advertising expenses that they spend. I've talked to a couple of marketing students over the years. I'd love to do an independent study on something like that. I mean, I'm sure that kind of stuff's been done, but I would love to become familiar with the literature on that. But yeah, maybe what we would do is, again, what we're trying to forecast, what we're trying to explain is sales. So maybe we look at the company's advertising expense. But even right here, we have an issue. Okay? If we're talking about sales at time t, that's supposed to be a t. If we're talking about sales at time t, are we going to use advertising expenses at time t? Or advertising expenses at time t1? So forth and so on. In other words, if we're trying to forecast the sales for the second half of 2013, and we're trying to forecast them with advertising expenses, which advertising expenses are we going to use? The ones that we're planning on spending for the second half of 2013, which we actually wouldn't know from the outside, okay? The advertising expenses that we used from the prior 6 months, the prior 12 months, et cetera, et cetera. Okay, so even with just one variable, we have a whole array of issues that we can talk about. And that's the challenge, and that's the fun of forecasting, in my opinion. That's the fun of it. Okay? I don't try and forecast sales, but I, just like everybody else, try to forecast stock prices. And that's the fun of it. Okay? All right, so again, this is just a simple example, so don't get hung up on whether or not the passage of time actually forecasts sales. All right? So that's the gist of what we're doing, and by a couple of different methods, we need to set the model. Okay? Because what we're going to do here is we're going to take these 5 years, actually the previous, well, in this case, I think it's just these 5 years, okay, to set the model, which is these two variables. Okay? And then for the year 2010, for example, we will plug 2010 into our model, do the math, and that's our forecast. Next year, 2011, plug 2011 in here, and that's our forecast. So forth and so on. Okay? So that's the process that we're doing, and what I have here is showing you several ways of doing the same thing. Some are more efficient than others. Some are, even though there are big ugly formulas in there, they're more descriptive because you can see exactly what's going on. Yeah, that's one of, as much as I like array functions, and I think they're cool, sometimes when you just look at an array function, it's not real obvious what the calculation is. But if you have a big ugly formula, like Tommy doesn't like from one of his prior classes, even though it looks ugly, it's more descriptive of what's actually going on. Okay? All right, so the first thing...
Oh, you don't have it up there. I got mine pulled up, and I just saw the one under year in sales. It's huge.
Yeah. Okay. The first one is the slide, and I just showed you this. Okay, this is the slope function. So notice that our y variables are b2 through b6, x variables are this, and this is the slope. Okay, so that's, what is it, 525, 245. 525, 245.
Nice.
That's the slope of the line. Okay. You can also calculate the slope, even though I never do it. There's another function called line estimate, L-I-N-E-S-T. Okay. You can also do it that way. I believe with that one you have the option to start changing the, you can change the constant, you can do something with some statistics here. I never do this, okay? In fact, I don't use Excel to do these calculations at all. All right, so if you ignore these last two things, the line estimate will do the same thing as the slope function. If you're trying to force a y-intercept, then you can use this function to do that. Okay? I never do that, so. All right, so far so good? Mm-hmm. Okay. Like I just showed you, next using the intercept function, okay, this sets the y-intercept, which is a negative, really ugly number. What is that? 1 billion, 1.05, etc. billion. Okay? So this is our model right here. That's what we set right there. So for the year 2010, using this function right, or excuse me, this formula right here is what I have written on the board, ignoring the error term. So what I have there in column D7 and D8 and D9 for that matter is what I have written on the board. Okay, so does everybody see that? So we have the intercept, which is in D6, plus the slope times the x variable. Everybody with me? Okay. So then, our forecasted sales for 2010 would be 4.3 million. Doing the same thing for the other two, 4.8 and 5.3. Okay, so in this case, all I did was use these 5 years to forecast these 3 years. Which is a whole other conversation. Because if we were at the end of 2009 and we're trying to develop a 3-year forecast, then this is probably about the best that we could do, assuming we only had 5 years of data. Okay? If we have more than 5 years, then we start getting into, or more, the more data we have, recall our conversation from yesterday about the balance between increasing our sample size and that sample size being representative of what's going on now. Okay, we had that whole big conversation yesterday. Okay, so if we were here, then that would be the case. But as we continue on, then if we're looking at a 5-year look back, then after 2010, we would need to adjust our model. So the forecast for 2011 would be 2006 through 2010. Okay. Which, of course, is assuming that we're just using a 5-year look-back period to set our model. Well, why 5 years? Yet another conversation. And again, I'm not saying that to try and antagonize you. What I'm trying to do, this is an issue identification conversation. I mean, in addition to using linear regression for forecasting, this is an issue identification conversation because you're going to have to address all of these issues in your forecasting efforts. Okay? All right, so questions so far. Everybody, so exam question. Given those data, forecast sales for, using linear regression, forecast sales for 2010, or 2011, or 2012, whatever the case may be. So far, so good? Okay. Oh, Don.
Why forecasting that multiplied by a year?
Because in this simplified example, for the purpose of illustration, we're just assuming that sales are going to be driven by the passage of time. Again, I have an example where I look at CPI, Consumer Price Index, and the unemployment rate as drivers of sales. Okay, so this is just a very simple example. Again, the main point here is the process of using linear regression to forecast, not whether or not these variables are actually, whether or not this would actually be a good forecasting technique, which we'll get into in just a second. Other questions? Okay, so that's column D. All right, all I've done in column E is put it all together. Okay, so this is just one big ugly formula in here, and all this is doing is combining these cells here. Okay, so if you want to just put it in one cell, there you go. I don't think there's really anything terribly interesting there. Okay, but in the last two columns, I've illustrated the use of two other Excel functions that you can use to do this. That's the forecast function and the trend function. Okay, again, I think one of them gives you a couple more options than the other, but if you're not using those options, then they'll both do the same thing. So looking at just the forecast, for example, when you pull up the forecast function, your input choices are the x that you're forecasting off of, and then the known y's and the known x's like we just did a minute ago. So if the exam question was forecast sales for 2010, then your x would be 2010. So that's what you're forecasting. You're setting the model based on these known y's and on these known x's. All right, questions about that? Yeah. Leah.
Yes, what is the logic behind it? How is it calculating this number? How is it coming up with this number? What is it doing? Is it getting an average?
Again, what we did was we set the model. So when I say setting the model, this is describing the historical relationship between x and y.
Yes.
Extremely simple example. If the intercept was 0 and the slope was 2, then what that's saying is that y is always going to be 2 times x.
Right. I see.
So whatever the x variable is, y is going to be 2 times that. In this case, sales.
Okay.
So whatever the x variable is, y will be 2 times sales. This isn't going to work, but extending a little bit from the year, if you had this, for example, which is sales at time t, and then sales at time t minus 1, then assuming t is a year, what that's saying is that your sales for the next year are always twice what they were last year. So obviously a very exponentially growing company, and maybe getting a little more realistic about it. Maybe back 1 point of 3. Okay. So sales for this year, in that very simple example, would be 3% higher than what they were last year. So they're growing at 3%.
Wow.
Okay.
Thank you.
Other questions? Other questions? I told you I like questions. I won't get mad if you guys are talking forecast. I won't get mad if you ask questions. Okay. And like I say, this is the trend, and I guess this gives you a couple of different options. Yeah, again, you can force a constant and that kind of stuff, which I never do that. I'm not going to ask you to do that on the exam.
You won't ask us to do what?
Force a constant.
Oh,
Yeah, because it'll take the line, but you can tell it to, for example, to always make sure that the y-intercept is through the origin. So then it's going to go through the OLR process like this, or you can say, like at your risk-free rate or something like that, and force it that way. I never do that. Not saying it's not valid, it's just not something I do. Other questions?
No way really different from the other, it's just different ways to calculate it.
Other questions? Okay, and I think that takes care of the rest of this stuff here. So again, that is using linear regression to forecast. Now, let's look at how we can assess different forecasting techniques and compare them to each other to see which one is actually doing a better job of forecasting. And that's critical. That's something that's critical. That's something I wish Tony was here today, because I've been trying to get that across to the Young Investors Club for a year now, and I don't think I've been successful. I can't get it in their head that, because the fun is coming up with all these forecasting techniques. Oh, you know, what's Apple stock going to do? What's this stock going to do? Well, that's forecasting. Okay? And that's fun, and I'm with you. Okay, I'm in. I like doing that too. But it's at least as important, in addition to doing that, now you got to go back and see what you did to see whether or not it was any good. Okay? Because we get in there and we talk about all these forecasting techniques and stuff, and it's a lot of fun to do it, but that's only half the story. The other half of the story is to determine whether or not there's any validity to it, because extremely important concept in forecasting and in linear regression. If you don't hear anything else I say about forecasting, hear this. Okay? We can find a relationship between y and x. Okay? So let's say we do this, we apply all of our statistics and stuff you're doing in quant tools and all that, and we find a statistically reliable relationship historically between y and x. Does that necessarily mean that that's going to continue into the future? No. Just because we find a relationship in the past doesn't mean it's going to continue into the future. Moreover, especially with things like stock prices where we have a long time series, daily stock prices on IBM, oh my gosh. I mean, we have a sample size that'll satisfy anybody. The problem is that even if that data is truly random, if we look at that data long enough, this is incredibly important. If we look at that data long enough and in enough different ways, we will find a relationship. Guaranteed. You will find something. That's what's called, and if you had Gilkinson with investment analysis, I'd be shocked if you didn't cover this. That's called data mining. Outstanding. Data mining. You'll also hear it called data snooping. I like data mining better. Data snooping sounds like Scooby-Doo. Okay? It's called data mining. Okay? You look at a set of the joke in research is if you take any given set of data, if you torture it long enough, sooner or later it will confess. Okay? That's a joke in research. Okay? You look at something long enough, you're going to find relationships. That doesn't necessarily mean that it's going to continue into the future. The issue is what's causing it. That's the issue. So causality, in my view, causality is all important. It's not enough to find a relationship. You got to know what's causing that relationship. That's important for two reasons. One, it's important to have confidence that this is going to continue into the future. And two, it's important so you'll know when to stop using this forecast. That's what used to always kill me in stock forecasting. You come up with a system or whatever. I think I probably told you guys the first day of class that one of the things that led me to a PhD in finance is that I ran across certain questions in my research and I didn't know where to go, and I asked other people and they didn't know where to go. Well, this was one of them. Well, I have this system, it worked in the past, it seems to be working right now, but when do I stop trading it? And a common answer that I got was, well, you stop trading it when it stops working. Well, that's the wrong answer. Because in any given forecasting system, it's not going to be perfect. Which means some years it will work good, and other years it won't. Okay? So you could have a good, valid forecasting system and go through periods where it's not forecasting very well. Okay? That's the nature of uncertainty. Well, but if you have a system that, so given that you have to ride out those down times, if you wait to figure out, oh, well, my system's not working anymore, you've given back all the money you've made. Okay? But if you know what's causing it in the first place, then you have a better shot at actually taking your profits and going home and not giving it all back. Okay? If we find a relationship with no cause, that's what's called a That's what's called I'm just curious if anybody else covers this. That's what's called a spurious relationship. Not to be confused with Steve Spurrier. A spurious relationship. Okay. There's a classic, actually there's several of them, but I think the one that's in the investment analysis book is the classic example of where they're looking for predictors of the S&P 500 index. And they find a statistically reliable relationship between, I don't remember whether it's the AFC or the NFC, but whichever conference wins the Super Bowl is a predictor of how well the stock market does the rest of the year. Did a study, statistically reliable and all that. Does anybody in here really believe that the stock market, that the Super Bowl results are driving the stock market? Does anybody really believe that? No. It's a spurious relationship. If you don't hear or believe or like anything else I say about forecasting, believe that. Questions? Questions? Okay. All right, so with that, what I have here are examples. Again, this is in your supplemental information that I told you about at the end of class yesterday. What I have here are just an example of 3 forecasting techniques. Okay? The first one is using regression, and I'm regressing the actual sales price levels. Okay, I'll show you the details in just a second. So this is, I'm calling it regression of levels. The second forecasting technique here is forecasting the regression of changes. So instead of using the sales prices, the sales levels, I'm using the change in sales as my regression inputs to forecast. And then the third one is simply a naive forecast, where next year's forecast is simply last year's sales. So for example, if last year's sales was 2 million, then we forecast this year's sales to be 2 million. This year's sales turns out to be 2.3 million, we forecast next year's sales to be 2.3 million. Okay? Again, what's important here isn't the forecasting technique, it's the analysis of figuring out which one's better. Okay, and I did it for General Motors and for Home Depot, just in an effort to find highly liquid stocks in different industries. Okay. And on this first sheet here, I'm using the mean absolute deviation and the root mean square error methods for determining whether or not the forecasting techniques are any good. That's what's in your that's what's in the handout that I told you about at the end of class yesterday. Okay. So what we got here is on the first one. Notice I'm using the forecast function. And what I'm doing is forecasting, actually it's this model right here. Okay. So I'm using a 2, 4, 5-year look-back period to look at the relationship between sales from last year and sales from this year. Okay. So everybody see that? So we've got our known Y's. I beg your pardon. This is using the date as the X variable. I beg your pardon. The A column. That's using the date. So this is what we just did a minute ago. Okay? So we're setting the model with 8 through 12. So, and by the way, these are actual sales. I didn't make up these numbers. These are actual sales through 2008. So a little bit outdated data. That's okay. All right? So we're setting the model with these 2, 4, 5 years. But in this case, it's a rolling 5 years. So when we go to the next year, we're including last year's actual sales and then dropping off the year before that. Okay, so everybody see that?
Do you always do that?
Huh?
Do you always do that with this?
No.
Oh.
I don't like words like always and never.
True, I remember that.
In this one, yeah, again, in just a simple
How do
example.
you know when to do that and when not to?
Well, in this class, I'll tell you.
Okay.
but that's actually a valid statistical issue, because this is what's called a rolling 5-year period or rolling 5-year look-back period. You could argue that, well, just for the sake of conversation, let's say that this was their first year in business. You could argue that, well, when you get to this next year, you have another year of data. So you would still want to start here to forecast there. But that gets into some statistical issues because the sample size that's used in the model isn't the same. And then, of course, as we get older and older, we get into the conversation that we had yesterday. And which one you should use is the one that's going to be the most accurate. And how do you determine which one's the most accurate? That's what we're doing right now, because none of them are, in addition to what I just told you over there, you can believe this as well, none of them are going to be 100% accurate. You're always going to have forecasting errors. Always. Okay? All right, so I use this to forecast the sales for 2005, for example. So there's the forecasted sales. Those are the actual sales for 2005. Forecast for 2006, actual sales for 2006, et cetera, et cetera. Everybody with me?
Mm-hmm.
Okay. With the mean absolute deviation, what we're going to do is we're going to calculate the absolute value of the difference. In other words, the absolute value of the forecast error. Okay. So in this case, we forecasted, this is in billions or billions, but we forecasted 182. Actual sales were 193, so we had a forecast error of 11. Everybody see that? Rounded numbers. Everybody see that? Forecasted 2003, actual 2004, so we were off by this amount. Okay? So notice the absolute value function in Excel, ABS. So this is how we calculate the absolute value in Excel.
Why do you want the absolute value?
To get rid of the negatives. Because when we take the average, if we have the negatives in there, it'll add up to 0. That should sound familiar. What other calculation are you probably familiar with where that comes into play? Geomean, and there's another one, which predates this class. Well, geomean probably is too. Standard deviation. Except that's not absolute value, that's the squared, which we'll get to in root mean square in a second. But the point is to get rid of the negatives. Okay? So this is the absolute value of our forecast error, and all we're going to do is calculate the average of that error. Okay? That is the mean absolute deviation. In other words, the average of the absolute deviations. The average of the absolute values of the deviations. Make sense? Okay. The second technique that I have down here, notice that I have them grouped, is that I'm forecasting the changes from the sales. An important concept to understand with regression is that almost always, and I can't think of an exception to this off the top of my head, you're almost always better off regressing the percentage changes than the actual values. Okay? That's as important as those things that I put up on the board over there. Okay? It's a time series property. Okay, so you're almost always better doing that. And that's what I have here. Okay, so the forecast, so we're still going off of the date, but what I've done is I've calculated the changes, the percent change in sales. This is your new divided by old minus 1 stuff. Okay, so from 1999 to 2000, sales went up 4.57%. 2000-2001, sales went down 8.44%, et cetera, et cetera. Everybody see that? Okay, so the first step here was to calculate the percentage changes, and then I used regression the same way I did before, except the x variable, instead of being the actual sales price level, it's the sales change, the percentage change. Right here. Everybody see that? So here's setting the model. Okay. The forecast is that sales will go up 1.59%. So if sales go up by 1.59%, that means we expect sales to be 198,464. So we got last year's sales times 1 plus 1.59%. That's what I have right here. Everybody see that?
Like, can you explain what that means again? Sorry.
What means?
1.59, you're saying you're forecasting it for what?
This is the forecasted sales change for 2005. So I took these changes here, plugged it into the regression model, okay, and the forecast for 2005 is 1.59%. So the forecast is that sales will increase by 1.59% from this year, correct? So that means we're forecasting sales go from 195 to 198. Actual sales are 193, difference 54.14.
Yeah.
Next year, using these changes here to forecast that sales, we expect sales to go up 5.37%, which means sales are going to go from 193, we project, from 193 to 203. Actual sales come in at 204. We're off by $1,000. Okay, so everybody see that? Okay, so with this technique, then we do the same mean absolute deviation calculation, average, and that gives us 12, 7, 12. So at this stage of the game, which exam question, which forecasting technique is better? Regressing the changes or regressing the levels? The changes. Because, of course, we want a lower error. So notice also that mean absolute deviation doesn't really mean much by itself, kind of like ratio analysis. Doesn't really mean much by itself, but it gains meaning when we compare it to others. Unless the mean absolute deviation is 0. That would mean something. Okay. Questions about that?
So just in case, okay, for clarification, the one that's lower is better that you're showing us right there,
Yes.
than the one we did up top. Then what do
Yeah,
they
because
do
the
about
error is
this?
lower.
Do they use this model for it instead, or what is the
Well,
purpose
I mean,
now?
just comparing these two techniques, which one appears to work better? And I say appears because this is, of course, a highly simplified example.
Right.
But which one appears to work better? The regression of the changes. So which one would you want to employ if these were your only two choices?
Okay.
Regression of changes.
Do they take that information in real life and like start trying to figure out why are we 17.23% on the lower end in the sales than
Of course.
this? Okay. I'm trying to get a big picture of what's the purpose?
Yeah,
Just
we're
the
all-
forecasting, sure, but what do we do?
Yeah, I
with
mean,
that?
we're all trying to forecast. Our reasons may differ, but, you know, well, we just saw it with our financing needs, the importance of forecast. So the example we used yesterday, I think our IGR was 1.67% or something like that. So if we're projecting sales to be higher than that, then we need to seek financing. But that assumes that our forecasting method is reasonably accurate in the first place. Okay, if it's just a wild guess, which some of them are, I mean, if it's just a wild guess, then it would be, in my opinion, kind of dangerous to start investing a lot of time and energy into raising financing when we really haven't the slightest idea whether or not we need it. Okay, so I mean that would be one reason. Depending on the industry, if we're expecting sales to go up, then we're going to have to buy more inventory, like we've talked about. Which means we might need to get on the horn with the suppliers, because the suppliers may not be able to supply us with that much inventory. They may not be able to supply us with that much raw materials to do what we need. So we might not just need to start seeking out other suppliers. On and on and on and on. I mean, I'm used to looking at it from the investment side. You know, what is it we want to invest in? Do we want to go long or short? How much do we want to put in there? Okay. Other questions. In fact, there's an article, I don't know if I have it posted on web courses, but I found an article called something like A CFO's Perspective on Forecasting. It talks about some of this stuff. So I'll post it on there if you remind me, if it's not already on there. Other questions? Yeah.
What happens if we don't need all the financing?
I beg your pardon?
What happens if we don't need all the financing?
Then you don't go get it.
What if we already got financing?
Oh, well, then you spend a lot of time and energy for nothing. And time is money. Energy is money too. But I mean, if you spent the last 2 months, interviewing investment bankers and, going through SEC regulations on how we're going to have to do this and so forth and so on, and then it turns out that you don't even need to do it in the first place, then you've just spent 2 months for nothing. Not to mention, you might have burned a relationship, because if you've been bugging the heck out of an investment banker for 2 months, trying to beat them down on their fees, and they finally say, yeah, okay, I'm tired of talking to you, yeah, we'll go ahead and give you a good rate, and then you call them back up and say, oh, never mind, we don't need it. Good luck trying to, number one, have a relationship with that person in the first place, but even if you do, good luck trying to beat them down a second time. Because if it was me, you're not going to be able to do it. Say, hey, we went through this before, and then we pulled out at the last minute. And relationships are important. That's one of the reasons why the first day of class I stress behavior in class, because that stuff's important. Attitude is important. Other questions? Other questions? Okay, and then the last one again is just a naive forecast. Okay, so we're forecasting 2005, it's just simply whatever sales were last year. We're forecasting 2006, it's whatever it was in 2005. Okay, there's our error, there's our mean absolute deviation. Okay, so of these 3 forecasting techniques, exam question, which one appears to be the best for General Motors? The changes. Which one appears to be the best for Home Depot? Last year. Okay. So again, with Home Depot, apparently we can go all through all these gyrations for these other 2, but we would have been better off just using the naive forecast from last year. Now the next question is, why? And I'm not going to ask you that on the exam, because that's like the whole point of this. Okay? It could be a coincidence, because these are simply spurious relationships, or there may be something driving this result. And answering that question is, in my opinion, of paramount importance. Because when you answer that question, that's telling you, that's your causality. And when you do answer that question, you're probably not going to be real anxious to share that with other people. Because that's your edge. We talk about having an edge, that's your edge. And by the way, that's what they mean. They may not know it, but when they say, well, what's your edge? Again, that's common in investment circles. Well, what's your trading edge? This is what they're talking about right here. They may not know it, but this is what they're talking about. Okay? All right, so questions about that? Questions? Okay, doing the same thing, our second, and again, the point of this is to introduce you to a couple of ways, a couple of performance evaluation techniques, a couple of ways that you can assess whether or not your forecasting techniques are worth a darn. Okay? The second way is what's called the root mean square error. Okay? And it's very similar to the mean absolute deviation. The primary difference is that to get rid of the negatives, instead of simply calculating the absolute value, we will square it, like we do in the standard deviation calculation. Okay? So everybody see that? So we're still taking the difference between the forecast and the actual, okay? But we square it to get rid of the negatives, whereas up here we were taking the absolute value. Okay? And I think they argue in the handout there that this would be appropriate when the bigger your forecast error, the more it costs you. Okay. So we do that all the way down here, and then, just like with MAD, we take the average of that error, but when we squared it, we blew it up out of scale. So for that reason, we also take the square root to bring it back into scale, just like you do with standard deviation. And that gives us a root mean square error for this forecasting technique for whichever one this is, of 26,229 for General Motors. Everybody with me on that? Okay. After that, it's the same process. So 26,229 changes are 16,830. The naive is 2593. Which one looks the best for GM? The changes over here for Home Depot, got 13,142, 8,000, and 3839. The naive. So both of them are leading us to the same conclusion in this case. That may not always be the case, but in this case it is. All right, with me? Okay. The last one, which is actually my favorite, although there's a limitation to it, which you'll see in just a second, is using R squared from our linear regression as the performance evaluation technique. Okay? So what we're going to do is use linear regression where we're going to compare actual sales to our forecasted sales. Okay? So we'll have actual sales as compared to our forecasted sales, go through our linear regression process, and calculate the R squared of the relationship between what was forecasted and the actual. In this case, how do we know whether or not our forecasting technique's any good? What would we look for? I think you said it. James, right? James, I'm sorry. Higher R squared. Because remember, R squared is explaining the variation between X and Y. If we had a linear regression model that looked like that, if we regress that, what would our R squared be? 1. Because 100% of the variation is explained by that line. Okay, so we're looking for a higher R squared. So what we have to do here in order to accomplish that is, and I was talking about this just a minute ago, is what we want to regress are the percentage changes, not the actual levels. That would be a big mistake to make. Again, it's a time series property. And the short version of the reason why is, let's say sales last year are 2 million. Okay? Remember I said that one of the assumptions here is that X is randomly distributed? Okay. Well, suppose sales last year were 2 million. Within the realm of reality, even in the statistical world, this year, would we really expect sales to be 0? No. Would we really expect sales to be 400 million? No. So as a time series property, there's what we call a permanent component and a temporary component. So what we would expect is, assuming sales went up, okay, we might expect sales to go up to maybe 2.5 billion or something like that. Okay, this is important. With me? All right. So this is our temporary component, and within the bounds of reasonableness, let's say that absolute worst case scenario, okay, sales might be down in here somewhere. Okay? This is the temporary component. All of this down here is the permanent component. So, if you regressed this level on this level, then what you're seeing is an artificially high positive correlation. Okay? So it's almost like regressing something on itself, which of course is going to give you a high correlation. Okay? But if you're regressing just the changes, then all you're dealing with is this right here. Okay, so whether changes go up 2% or down 2% in any given period, okay, let's just say that change is probably random, just for sake of conversation. That change is probably random. So we can't really predict whether they can go 2 million or down 2 million, or not, I'm sorry, up 2% or down 2%. Okay, so we really can't predict that, but what we do know is they're not going to be 0. And they're not going to be 400 million. Okay? It's going to be something in here. All right? And that's the very short, almost kind of layman's terms, why we regress on percentage changes rather than on the actual levels. That's critically important. I had a buddy one time, he was doing what's called pairs trading. We'll probably get into that a little bit more in the investing section. But the gist of it is you look at 2 stocks. Okay? And you find 2 stocks that move together. Okay? Well, when they start deviating from that, then you go long one, you go short the other, so it's kind of a zero-cost investment with the expectation that they would come back into line and start moving together again. He's using the correlation calculation to try and find these pairs. I'm talking to him on the phone. He's one of my old trading mentors. I'm talking to him on the phone, and he's quoting these correlations to me of like 0.9, 97%, 98%. I'm saying, you're telling me you're finding 2 pairs of stocks that have a positive 98% correlation? Yeah. Okay, so I drove all the way down to Lakeland, go over to his house, see what the heck he was doing. And yeah, he was finding that, but the reason he was finding that is because he was calculating the correlation based on the stock price, not on the stock change. That's why he was finding those correlations. When I pointed out that simple statistical property to him, and he started calculating correlations on percent changes, in other words, the holding period return, instead of price levels, what happened to his correlations? Yeah, they went down to what we would expect, 20%, 15%, something like that. Not a stupid guy, he just didn't understand statistics, and basic statistics at that. Okay? So that's why this is so important. Okay? So what we're doing here is, in this column, these are the actual percent changes. Okay? So the first thing you got to do is take your sales level and calculate the percent changes. Okay? Which is what I have here. We go through the forecasting process. So, for example, the forecast for 2005 is 182,027. That is a forecast of a decline of 6.82% from the prior year. Okay? So you got to calculate percent changes for both the actual change and the forecasted change. With me? Next year's forecast is 2003. or 203, which is a 5% increase over the prior year of 193. So forth and so on. Everybody see that? I'll take that as a yes. Then we use our R squared function like I just showed you. Again, you could, if you really wanted to take the time, you could do a scatter diagram, or you could do the data analysis like I just showed you. But regardless, we need to calculate R squared, and in this case, I'm using what's highlighted here as my X and Y variables to see how well the forecast explains the variation in the action, see how well they fit. And of course, we're looking for the highest R squared.
Can you explain that one more time, because you have the change over here is the known lines, I would have thought it was reversed.
Well, you'd still get the same R squared.
Oh, you would?
Yeah. Okay, so for the levels and then the changes, notice the difference just right there. So obviously, the changes give us a higher R squared. In fact, I mean, honestly, in real life, if you had an R squared that high, double check to make sure you didn't make a mistake. Because, you know, based on my experiences, I mean, if you're getting R squareds higher than probably 15–20%, that's like stellar. So make sure, and if you're getting R squareds at 97–98% like my buddy did, I'll go out on a limb and say you probably made a mistake somewhere. Okay? You can't, nobody has that good of a crystal ball. Okay? Now, analyzing the past is a different conversation, but forecasting the future, Okay. But with this, we have a problem using R squared in our naive forecast because all of our forecasts forecast a 0% change. So there's really nothing to regress there. And that, I like this because with the R squared we can apply statistics to it, or it's easier to apply statistics to it to give us some confidence as to whether or not we're actually finding something. Okay. The disadvantage is that in a naive forecast like this, it breaks down because there's simply nothing to regress. All of our x's are 0. Okay. And of course, I did that over here with Home Depot with similar results. Okay. And I also, just for comparison, I calculated the mean absolute deviation and the root mean square of the percentages rather than the levels, and it leads you to the same result. Okay? So again, the summary of all of that today is, number one, just getting familiar, if you're not already familiar, becoming familiar with using linear regression as a forecasting technique. And number two, more importantly in my opinion, is beginning to use some techniques to determine which forecasting technique is better than the other. And that's, again, in my opinion, that's the important part right there. And I will get that across to the Young Investors Club if it takes the rest of my career. I'll get it across to you sooner or later. So that's not quite, I think it's fun, but apparently nobody else does. Okay. And I've also irritated some of my former trading mentors in these conversations because, you know, they do all this trading stuff, but then when I start applying statistics to it, and I point out to them, well, it doesn't really look like there's anything, and they get their egos right, they get all mad at me. In fact, the guy I was just telling you about, after I pointed that out to me, he didn't talk to me for 6 months. And then finally came around, you know. We go through these 6-month cycles where I point things out to him that he really doesn't want to hear, and he gets upset with me, and I don't hear from him for a while, and then I guess he gets over it, and then we do it all over again. And not a stupid guy, just doesn't understand econometrics. That's why you guys took quant tools. That's why you guys took that class and the other stats class. Did I see a hand? Questions? Okay, so that wraps up chapter 5. All right. Chapter 7, again, is on time value of money. I'm not going to insult you by talking to you about future value, present value, ordinary annuities, annuity due, okay, IRR. All right, I'm not going to insult you by teaching you that all over again. However, what you want to do this weekend for Chapter 7, you're responsible for all the homework in Chapter 7. I'm not even going to go over it, okay? You just need to go through it. In Chapter 7, they talk about graduated annuities, and I'm not going to get into that with you, okay? Like I say, my goal for you is all the calculations you can do on your calculator, make sure you can do them on Excel too, and the way you verify that, in addition to doing it on your own, is go through all of my spreadsheets, okay? So I've got a whole bunch of examples on here. Here they are. Here's the proof of them. So starting with simple things, and then I go up to things that are more complicated for 34-3 crowd, but not for you guys. Make sure you look at the amortized loans. So if you don't know how to prepare an amortized loan, that is something you most definitely need to know as a graduating finance major. You need to know how to prepare an amortized loan. So make sure you look at that. If you don't know that, make sure you look at modified internal rate of return. Okay? I know you've talked about IRR. I'm sure you've talked about modified IRR somewhere along the line, but make sure that you re-familiarize yourself with that. Okay? I have a few examples there. At the end here, I have one of my favorite types of time value of money questions, which is planning for your college. Not for your college, for your kids' college. Or planning for your retirement. Okay? Questions like that. So your task over the weekend, among other things, is to go through this spreadsheet and make sure that you can do all these calculations. Again, this Chapter 7 will largely be driven by your questions. So if you're not familiar with something, if you need a refresher on something, let's talk about that and let's make sure that happens. But like I say, at this stage, I feel like I would be insulting you if I taught you time value of money all over again. Okay? All right, so questions about your task for Chapter 7. By the way, I have supplemental homework questions for most, if not all, these chapters, especially on Chapter 7 with time value of money. I have supplemental questions on there which will give you an idea of what to expect on the exam. Okay? So questions about Chapter 5 or Chapter 7, even though you're just seeing it, this time value. Questions about any of that? Okay, look at both of those over the weekend. On Monday, we'll go through Chapter 6, which is on leverage, degree of operating, financial, combined leverage, some other things. So we'll go through that on Monday to the extent we need to. That'll spill over a little bit into Tuesday. We'll start going through homework on Tuesday. To the extent necessary, that'll spill over a little bit into Wednesday. And that brings us into the exam on Thursday. Okay?